The broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning, good afternoon, everyone. My name is Marwan Altai. I am a product manager working for SCIA since 2015. Today I'm going to be with you in this webinar. I'm going to explain to you the new content regarding the concrete design in version 19. Before starting, let me check if the sound is okay or not. If you can please type something to confirm that the sound is clear and the image is okay. Everything is okay. That's good. Thank you very much. In fact, in this webinar, I'm going to do two things. First, I will review a little bit the previous release. I would like to give you an overview how you can design a concrete structure using SCIA Engineer. The second part, it will be for the new content version 19. A quick reminder to you, if the sound is not okay, you can play with the sound panel or the audio panel. During the webinar, you can ask your question. I will try to answer that after the webinar, in fact, not during. Unfortunately, today I'm alone with you in this webinar because it's a public holiday in Belgium, so no one with me to support or to answer the question. So you can still type your questions. I will answer the question after the explanation. And if the time is not that enough, then definitely I will come back to you by sending email. To anyone who would like to watch the webinar later, it will be published in our website or in our YouTube channel. So let's move on, in fact. Quick question. I have a beam. How can I design it with SCIA Engineer? Basically, today in SCIA Engineer, there are three different ways how you can design your beams, columns, ribs, whatever you have. There are three ways. And maybe someone will ask me why there are three ways. In fact, there are three ways in SCIA Engineer because in reality, you can face different type of structure. Imagine yourself, you designing multi-story building, you need a specific need. Someone else who designing infrastructure, he needs something else. And also the experience of the users, the experience of the concrete designer could be different from one person to another person. I am experienced guy, I'm doing a concrete design since many years. Then I don't need exactly what the just graduated engineer needs. There are some differences between the needs of us. For that reason, we designed SCIA Engineer in the concrete design to somehow meet those kind of criteria, different structure and different experience. And that's why we have different workflow. Again, I will explain the main workflow, the first one. As a concrete designer, I have a long experience. I can decide from the beginning the amount of the reinforcement. When I see just the internal forces, I can little bit predict how much the final reinforcement will look like. And in that case, I can use this workflow by modeling all the reinforcement inside my beams or my columns. And then to be sure, I will ask SCIA Engineer to check if those amount of reinforcement is okay or not. So this is the main workflow. What is the advantage of that workflow? Quite straightforward, quite clear, easy to learn, and it's applicable to any kind of shapes. If you have the ability to model your cross-section in SCIA Engineer, then definitely you can check if the reinforcement is okay or not. And you know, in SCIA Engineer we have checks for ULS, checks for SLS. And of course, after modeling this reinforcement, you can use the checks to be sure that everything is okay or not. So this is basically the first workflow. Now, I am another guy. I'm working in a control office or in control bureau. Normally, every day I'm getting projects. It's already designed by another companies, but my job in that company is to control if the design is okay or not. What should I do? Modeling the rebars, modeling the reinforcement, it will take time from me. This is something not practical. I need something else. And for that reason, we have section check, where the workflow is quite easy. Just select the member and then select the point where you would like to do the checks. And then you will have all the ULS and SLS checks together. Third workflow, I'm a different person. I would like to design multi-story building. I have many elements. If I will model my rebars manually, then it will be nightmare. I will not do it. And if I will do section check for critical sections, imagine how many critical sections do you have in your structure. So both workflow will not fit in my need. I need something else. And then SCIA make another option for you, which is designing based on basic amount of reinforcement, putting a basic amount everywhere, and then calculating the additional amount of reinforcement, which is very fast workflow, ideal for multi-story building. Those are the main three workflow that the majority of our clients using today in SCIA Engineer. But all of that, it was in 18.1, so it's not new. And maybe you feel boring now because I'm repeating that. In fact, I'm repeating that because the new development, it's quietly linked to what we have released in the past. Now let's see how SCIA Engineer 19 accelerated the design. And I will start with the first improvement in this new version. It's design of the shear reinforcement. Most of you familiar with this window, which is the definition of AS basic and AS additional, right? There is something missing in that window, which is the stirrups. In the old version, we can design shear reinforcement, but the design was theoretical amount, not practical. You will see today in version 19, I will talk a lot about the practice because this is what we try to do. In fact, we can try to accelerate the design by making the calculation very fast. That's true. But also, if you spend a lot of time after the design, and then the software can somehow solve the issues that you need to solve after the design, then definitely you will win a lot of time. We will see that anyway. So in the new version, in 19, we have introduced a new library for the stirrups. What you can do, in fact, the user can select the stirrup shapes directly from this window, and then the stirrup shapes will be selected automatically, will be respected, I mean, for the calculation of the longitudinal reinforcement. Other options, we have it in this window, which is a new maximum number of zones. What's the meaning of that? Let me draw something quick. If you have a beam like that, and then when you are making your stirrups normally, you are saying I need, for instance, from this location to that location, I need one spacing, and then from that point to that point, I need another spacing, and finally you have another spacing. So this is in fact zone number 1, zone number 2, or zone number 3. This is how you can decide, or you can tell the software the maximum number of zones. Number of cuts, it's automatically calculated based on the selection. If you selected this shape, it will be 2 cuts. If you will select another shape, it will be automatically calculated. Next, diameter. I can decide the diameter from here for the stirrups. Multiply, what's the meaning of that? If you will select 50, it means that the spacing between the stirrups, it will be a multi of 50. For instance, either 50 or 100 or 150 or 200, something like that. If you don't want it like that, you can make it, for instance, 10. Then the result, it will be like 50, then 60, then 70. So it's a way from SCIA to little bit make the output not theoretical. Like in many cases, we get we get the stirrups spacing 153, 3 millimeter. In fact, in reality, doesn't mean anything. I will not give my drawings to the laborers with 153. They will start laughing. So I need to make it somehow practical, and then you can introduce the value here. Another option for more practical users, people who use always the same spacing, then you have another options here. Instead of multi, you can choose user input, where you can input the values automatically by yourself. I mean, not automatically, but you can input the values, and then SCIA will use those values automatically for you. Next option, symmetrical. Why we are giving a symmetrical? Maybe for us as a designers, we don't care where is the left of the beam and where is the right of the beam. But imagine yourself, or imagine the laborers at site, where the left and the right is quite important for them because the stirrups or the reinforcement is not symmetrical. But with this option, you are telling the software that to put the maximum or the critical value for the stirrups from the left equal to the value from the right, or opposite. So always you will have, in fact, two zones. The middle zone, which one with one value, and zone number 1, it will be always equal to zone number 3 when you activate the symmetrical. Let's see something more practical now. I have this beam, very simple case. And when I decided to use SCIA, the new version, SCIA automatically calculate the zones for me like that. Question. Okay, I decided number of zones, but based on what? SCIA decided to decide the length of that zone. As you can see, it's from here to here. In fact, what we have in this new version, we have a new way, or two ways, in fact, to decide the length of the zone. The first one is very practical because it's always based on the geometry. Imagine you have a 9-meter beam, then based on the geometry, SCIA will say 3 meter, 3 meter, 3 meter. Then SCIA will search the most critical spacing in that 3 meter, and then you will get the value. For instance, 177. Okay, then another 3 meter, SCIA will check in that 3 meter what is the most critical one, and then SCIA will decide the value. And based on that, you will get 3 values per span. Maybe you will ask me, is it per member or per span? No, it is per span. You know the difference between the member and the span. I will not explain that. Anyway, this is the first way based on the geometry. Is that economical result? I'm doubting, because it's very practical, easy for the laborers to implement the stirrups, but it is not that much economical. If you are looking for more economical result, then we have another options for you. It's more based on the frequent distribution, and I will explain to you the idea how we made that options. This is my beam, and I'm going to draw the stirrups or the shear forces. Imagine it is as a simply supported, something like that. So the result, it's like that. The idea from this frequent distribution, you know, in the center here, almost we have no shear forces. So what we need to apply? We need to apply ASW minimum. And let's imagine we will apply AS minimum. It will be somehow fit from this point to that point. So in fact, SCIA calculated the first zone, which is zone number 2, based on AS minimum. And then from this point to that point, SCIA will check the most critical value, normally this one, and SCIA will apply this value here, and then the same from here. So this is the way how the most frequent distribution is calculated. Why I'm saying it's very economical, because I have compared the two results between this one and that one, and I checked that it is more economical. And the way how we are doing this AS minimum and then extend the value of AS minimum, somehow it's giving more economical result. Next. I guess you are familiar with the old solution from SCIA Engineer, or how we call it REDS, the practical bar. In order to see the advantage of the new version compared with the current solution, first thing I decided to do the same stirrups like that, because this is stirrup in fact automatically done in the new version. But in order to do the same in the old version, in fact, I see that I need 15 clicks. So the first advantage for you, you already saved 15 clicks, and you don't need to play with those zones manually in the new version. This is number one. Next one, how can I be sure that the practical output or the practical automated calculation from SCIA is okay or not? Always you can combine the theory calculated value and the practical value. You can see those two colors here and here. The difference are, this is the real and this is the customized based on the zones, based on the factor of the spacing, and you can see the difference between them. And always SCIA will give you some nice unity check to feel more comfortable, right? I'm going to show you that in SCIA Engineer. I made this very simple case. I will go here and I will calculate the shear reinforcement. As you can see, the shear reinforcement is calculated automatically. So here I have 100, 250, 150. The question now, how can I play with the option? Normally the option, you can find them in the design default. You see those new items. Those new items, in fact, it's all of them in version 19. Let me explain the one which is related to the spacing. Here, either you can say, no, I would like to have AS provided exactly equal to AS required, then you don't need to play with the zones. The second one, geometrically, then you will get some geometrical explanation. By the way, what you have, it's 19.060. There is no explanation here. This explanation will come in batch 1. Somehow it has been missed, but it will be come as you can see with the rest. We have some explanation. This one also should be explained, and I have seen it already explained, but not in this version. Maybe I will answer a quick question came to me. How does the none type of zones work? In fact, it will be equal to, if none, it means there is no zones. It will be exactly equal to AS required for shear reinforcement. So ASW required. There is no distribution in that case. So it's a quick option from here. You can choose how it is decided. Anyway, so I will select the geometrical, and now I will do the calculation again. Yeah. Yes. So this is the way on the geometry, or based on the spacing. So two options. To go back to little bit to show you how you can decide or define the layout. So this is the shape of the stirrups. You can choose this shape or another one, and as you can see, number of cuts, it will be calculated automatically. Keep in your mind also something new in this version. In this version, there is a new place where you can define the detailing diameter. If you are familiar with SCIA Engineer, then you will understand what I'm saying. In the past, if SCIA need to cover some rules from the detailing rules, then SCIA will add bars based on the diameter of the main longitudinal reinforcement, which is somehow not practical. Now in this new version, we have a list you can choose what you want, and this diameter will be used for detailing bar. As you can see, in the template, I define the top reinforcement as 2 bar. So this is number 1 and this is number 2. But SCIA automatically add gray bars for me. The diameter is 10 because those are detailing bars. There is something really important I would like you keep it in your mind. Those gray bars will not be used for the calculation of the capacity of the cross section. So if you would like to compare MED with MRD, keep in your mind, if the bars are gray, then they are not used. The best scenario in that case, if you would like to use this shape of the stirrups, instead of 2, use 4 bars. And then those bars will be used for the calculation of the MRD. I think it is now clear for you. Okay. So I will go out from this. In fact, this is the shape for the rectangular, but also if you are interested in doing ribs design in SCIA Engineer, then you will have also something for the ribs, for the T section, and as well as something for the L section. All that is calculated automatically. Yeah, from time to time I'm trying to read the question, but it will not be okay to keep answering all of them. I will continue now with the new advantage of the new version. Now it's not regarding the stirrups; it's regarding to the longitudinal bar. Uniformity of the reinforcement above the support. In many cases, or in some cases, let me be more precise, you will get a bending moment from the right side, not exactly like the bending moment from the left side, especially when you are modeling your beam as pieces. So I have modeled this piece from here to here, and then this piece from here to here. Then it could be that for some reason, because of the load, you will get here low moment different from the moment here. If I will go to the AS required, then definitely AS required, it will be also different, 3 bar 16, 6 bar 16, right? Is that practical? Definitely not. I will not do it like this in reality. So I need to have somehow a uniformity above the support. And for that reason, we introduce a layout, or not layout, option where the user can introduce this kind of uniformity. But there is a limitation. The limitation is, if you modeled your beam as a single beam from this point to that point, then another beam from this point to that point, then this functionality unfortunately will not work. The plan was to make it work in this version, but we have faced some difficulties and it is not working. So how you can get a uniformity? Then you need to make a continuous beam. So you have to merge the beams together, or you can model the beam as one point from here to here as one. Yeah, okay. So this is the advantage also in the new version. Next question is, if when we see AS required, it's 6 diameter 16, the question is coming to my mind, up to where I will extend those bars. Because here calculated the reinforcement in this specific section. In the next section, it is another value. But in reality, I need to make some decision. I need to make it something practical. Then you will have option, which is minimum length of the longitudinal bar. By default, it's 1 meter. So here it's maximum. See, I will extend that maximum to 1 meter. Right? The same here. The idea is to give, again, to make the result more practical. Next option, or next improvement, designing with 4 corner bars. In the past, somehow it is not practical, or it is not easy to design columns with only 4 4 corner bars, because I don't know which diameter will fit, because I already fixed the number of the bars, only 4 bars, but I don't know which diameter will help me. So with the new solution, what you can do, you can select 4 corner bars and give a list of diameter to SCIA Engineer, and then SCIA will make a kind of iteration to find the best scenario for you. This is also something practical. It could be used if you have simple projects, houses, or something like that, where you need to see the result always as 4 bars, something like that. Now I will go back to SCIA Engineer. I will choose a different model. What I have rectangular, T section, L section. What I'm going to do, I'm going to do the calculated, I will call the calculated reinforcement here, which is the provided reinforcement. Already I defined the number of zones, all that, it's done. There is something new in this version, I didn't explain it yet, which is the automatic conversion of the bar. Here, keep your eyes here, conversion for real bars. If I will click here, see, I will give you a message. After the message, then you will get all the reinforcement converted automatically to real bars. Again, I would like from you to remember the first workflow. We said the main disadvantage of the first workflow is always I need to model those real bars manually. With the new version, in fact, not only the conversion became automatic, but also we respected something from the reality to make the reinforcement more practical. As you can see, for instance, those 2 bars extended, and then I have 2 bars from here to here, and finally I have those 6 bars. The same thing for the T section, the same thing for the I section. The advantage now, what I can do, I can quickly jump to the capacity. I can use all those checks easily because I don't need to model. Normally you should see unity check equal to 1 or less than 1, because all those checks, in fact, it's ULS checks, and what I have here, it's also ULS check. So I guess this will save a lot of time. I see, somehow your question somehow distracting me. I see a question, is those real bars exportable to IFC? Yes, and this is what I try to explain. Now I have the reinforcement in SCIA Engineer for those 3 types of cross section, because those only the 3 sections supported for the beams, and those are for the columns, circular and rectangular. Now, what I can do with those reinforcement, I can right-click, save picture to file, and then I can choose DWG. I can send it to AutoCAD or whatever CAD software. I can send it to the IFC format. I can export it to Revit and Tekla. Revit and Tekla at this moment in this version still not working, but we are working on it. Again, the plan was to make it possible in 19, but unfortunately some delay happened, and it should be in patch 1 for Revit specifically. And now what I can do also, which is something really I like it, I can go to MED, MRD and make the comparison to be sure everything is okay. So let's select this one and keep it on the screen. Make it like that. And then you can compare the 2 values and you can see how SCIA played with it. I'm going to go back to the main presentation to not lose time. Okay, we already 30 minutes now. I will explain to you now the advantage quickly. What we did, again, we did practical automated way for the shear reinforcement. We give some options to make the output somehow match the reality or the needs of the laborers. But is that applicable on multi-story building? Let's try it. In fact, I tried this new version on this multi-story building, 8 floors supported by columns, a lot of beams. What I can tell you, I spent in fact 1 minute only to run the design and do the conversion to the all bars. Just 1 minute. Maybe you will say you are exaggerating because you have very simple case. You don't have a lot of load combination, and in reality you have a lot. I fully agree with you. But my point is to show you now you can little bit start changing the way how you are designing a concrete structure. I'm sure many of you still using Excel sheet today, or many of you still using small application where you are reading the internal forces from SCIA Engineer and doing the design in that app. That's fine, but you can start using V19 and doing the design for the first time in one click for everything in one go. The advantage, you will convert all the bars automatically, but also, let me show you this image here. Also, you can run the check for everything in one go. Maybe you will say, stop Marwan, you are exaggerating too much today, because I cannot read the result here. In fact, my point from giving you this unity check is not to show you the value 0.96 here. What I would like from you to see is the color. If the color is green everywhere, that's it. If you have some red spot, then you easily can find out where is the problem. And as you can see, I have a problem in this column, in that column, and in that column. So I know it's a new way in the design. You are not used to see that new way in the design because the majority of the clients somehow taking one beam, doing the design in that beam, and they are assuming this beam is similar to those beams, and you are making a kind of design group, and then you will start wasting a lot of time. So I think what we have today really it will save the time for you. Anyway, what I also did before the release, I decided to contact one of our clients to little bit make some testing. I asked from this client to do the design based on version 18, right? 18.1. This client, for your info, it's not a normal client. It's really supervisor. He knows SCIA Engineer more than 20 years. And he told me that he spent 5 days to organize all those real bars like that and playing with the spacing. Then I decided to use version 19 to do the same automatically. What I did, in fact, I spent only 5 minutes to get the same result. So you can imagine how much time you can make, you can save. Then I came back to this client, Mr. Vreeling, and this is his feedback. So it was a nice feedback from him, right? This is already explained where you can see the colors, and the colors will guide you where is the problem. And always when there is something not clear, always you can see how the output will explain that to you. I'm going to go back to again to SCIA Engineer. Let's take a look on a different model. I have somehow one plate supported by all those columns. I'm just trying to give you a feeling about the calculation. I'm going to calculate the provided reinforcement. I did some definition in the background. Now SCIA is calculating for 50 elements between beams and columns. Now the calculation is done. What I'm going to call AS provided. AS provided is like that, so easily I will click and then do the conversion. Voila. As you can see, all the reinforcement, it's converted automatically, right? What I can do now, I can go to the checks, calling capacity check. And before I miss something, I would like to mention something about a message we added in this new version. Please read this message with me. This is quite important. In order to avoid any confusing in the future, we decided to add this message for you. Longitudinal reinforcement is designed in the center of the edge of the cross section, while those checks here, in fact, they are depending on the real position of the reinforcement. What does that mean? It means that in some cases, you will design the reinforcement here, like what I did. I designed all the reinforcement. I clicked refresh. Then the reinforcement is calculated. Then I will convert the bar automatically, and then you will get all the bars. Normally, what I'm expecting when I'm doing a capacity check, I should see everything green. This is the normal case. But in very small cases, you will not get it as red. You will get some differences between the value here and then the value here. And this is somehow confusing case where as a user I will say, okay, the design asks from me to put 6 bar diameter 16, but the check asking from me to put 7 bars. Which one is correct? In fact, it's both correct somehow, because here we are depending on the methodology of designing in the center of the edge, right? And then we are using a kind of factor to redistribute those reinforcement to the width of that edge, while the checks itself using the real location of those bar. And somehow this is more precise, in fact, because we know exactly where is the location of the bar, then we can exactly calculate the effective D, or the distance from the center of the bar to the neutral axis for the calculation of the resistance. So please don't be confused and expect that you will get some differences between the design and check, because the design today, what we have it in the center. Yes, this is what I try to explain to you, right? I'm going to have a look quickly to your question before going to the next topic, because the next topic it's about the 2D design. The first question is about the distribution. I already answered this question. Yes, there are a structural bar, or how we can call them in some cases, face bar. I can tell you also something nice. I like it. I'm going to little bit rotate this beam. What I'm going to do, something like that. How much I have here? Rectangular. I have 650, 400, right? So as you can see, the height is 600. For that reason, according to the code, the minimum spacing between the bars shouldn't be more than 350 millimeter. But now, for that reason, SCIA added those 2 bars for you automatically. Now, if I will change the cross section and I will make it bigger, SCIA will automatically add those bars. But those bars again will not be used in the capacity. Next question, maybe I missed to explain that to you. How can I convert, or not convert, how can I edit those reinforcements? For instance, here I have 2 bars. I'm not happy. I would like to make them 3 bars. Then if you click on the bars themselves, then you will go to the property. You will see in the action there is something new. We call it edit reinforcement. If you will click on the edit, You will see all the colors became completely different. And then SCIA, in fact, will ask you, select the reinforcement layer. How many layers we have? We have one layer for the basic reinforcement. This is the basic. As you can see, I can highlight them together. If I will click on them, I will get the property of the basic. Type basic. I can make it 3, right? Now I have 3. I can change the diameter. And I cannot change the length because the basic bar always from the end to the end. Okay, make it 2 again. If I will click on escape on the keyboard, then I will get out of this layer. Still, again, SCIA will ask me, select layer. I can select the stirrups in that case. And in the stirrups, you will see zone number. Let me take it little to here. Zone number 1, zone number 2, zone number 3. And then you can start playing with the spacing. Is it possible that I can keep the zone as it is, but add local stirrups from this point to that point, for instance, like what we have in the old solution? Unfortunately not. This is not yet developed. So because it's automatic, you can do the edit only from here. So you can change the diameter, and also you can change the way how you are seeing the spacing. For instance, here the spacing is 200. Where is it? Distance, it's 150, which is from the face. So this value, it's 150. It's from the face, as you can see it. But the spacing of the real bars, it's 200. But I can change it to according to the begin and end. What does that mean? The differences between them. If you would like to fix the spacing, then somehow SCIA obliged to play with the start point and the end point to keep the 200 constant for you. But if you would like to fix the start point, then SCIA will little bit optimize the value that you introduce in your solution in order to make it fit inside the zone. I hope this will not be something to confuse you. Again, I will select another layer. Now I have 2 bars. Let's rotate it. I have 2 bars, and then I can play with those 2 bars. To anyone who likes always to have anchorage length, I think you will ask me, is the anchorage already calculated automatically? Answer, no, sorry for that, it's not implemented. But we decided to give you the option where you can input the value manually here. For instance, I will say 0.6. And as you can see, SCIA from this point to that point decided to increase that visually. So there is no calculation at all. So if you will go to the detailing provision, you will get nothing about that. It's just visualization and maybe a step to the draftsman where before you are exporting the result to him, you can extend them. Another question maybe you will ask me, can I make hooks? Unfortunately not. Keep in your mind, this was really huge project, and we were struggling. We were thinking, should we in fact release it in 19 or keep it hidden? And then I contacted a few clients, and one of the clients who answered me, he said, you already saved us a lot of time with the automatic conversion, so we can wait another release to have the anchorage or the overlaps ready. For that reason, we decided to release it as it is. Next point I would like to tell you, now I will select the layer. I will skip. If I will select the detailing bars, as you can see, then here they are, detailing bars. From here I cannot change them, I guess. Yes, I cannot change them. But what I can do, in fact, to see the influence of them, I can use section check. Till now, nobody asked me if the section check is still working with these reinforcement or not. In fact, yes, if I will go to the section check, I will select this point where I have many reinforcement. Okay, as you can see, automatically SCIA recognize those reinforcement, and then for the detailing bars I can deactivate them to see if those bars became real bars, not structural bar. What's the influence? So section check, again, it is working in this version. Another thing I would like to mention it's here in the design itself. You have what is it? You have several possibilities. Please use them. It's quite useful. Unity check comparing AS required with the provided. Here it's a comparison. How much your reinforcement is active. Do you waste a lot of reinforcement? As you can see, somehow between 80 and 90% of your reinforcement is active. That means the design is already optimized somehow. Another unity check to keep your reinforcement away from AS max. We are giving this unity check as well. And always you have this option here. Somehow it's hidden, and I'm getting a lot of question. Can I compare the required with the provided? It's already exists in the software, but somehow people, they don't know where is it. It's a comparison between the required and the provided, just to feel comfortable. Can I see beam capacity? Yes, I already explained that. A question is about the ribs. Well, the question is, does SCIA understand if there is reinforcement inside the slab? Well, normally you will not get the top reinforcement in that connection. I mean, if you have a rib, and then in the flange it will be belong to the beam. So if you will calculate the longitudinal reinforcement for the slab, you will not get top reinforcement in that spot. Normally not. So the reinforcement, it will be directly moved to the flange of the beam. But the question, if you will put real bars there, what will be the scenario? Good question. I don't know. I need to think about it. So I will think and I will answer the question later. But now with the new solution, it should be automatically converted, and even if it is rib. Okay, I need to move. Sorry for that. I will not continue with the question because there is something also nice. I would like to mention it about the 2D design. With the 2D design, most of you familiar with the old solution, defining basic amount and then calculating the additional amount of reinforcement, right? And then you will get those color. I don't know if you like this solution or if you don't like it, because it's somehow only SCIA using this methodology of defining the reinforcement via template, not like other software. There is something new in this version, which is a combination of template reinforcement coming from here and maybe the real bars. In the old solution from SCIA, normally you can model a real bars inside the slab. Let me open SCIA. Well, not this one. Again, not this one. User reinforcement. Okay. So I have this case. In this case, what I can do, I can go to the reinforcement design and I will calculate Let me deactivate this one. Don't look here. I deactivate this one. What I'm going to do, I will calculate the provided reinforcement. See, I'm now checking the internal forces, the required one, and then doing the provided reinforcement. And the provided reinforcement could come like that, many colors, because I little bit opened the definition. The new advantage of the new version, I can combine the template reinforcement with the real bars like that. So if I will draw a real mesh here on top of that column, and then I click on this tick box, consider user reinforcement, then the result, it will be like that. How it is became like that, more easy, more friendly, let me say, because in the definition of the template, I will go back. What I have, not this one, sorry. In the definition here, I defined diameter 10 everywhere, and I gave two different spacing, 250 to the top, 150 to the bottom. And then I gave some condition here. So what I have, in fact, I have 10 to 150. This is my basic amount of reinforcement. Now, if I will calculate, you will see 10 diameter 10, 250, still my basic amount of reinforcement everywhere. But the user decided to put his real bars on the top of the column for many reasons. Could be one reason to avoid punching, could be to avoid CDD calculation, or it could be to avoid this not nice or weird shapes where the reinforcement is like that. If you are still interested in seeing the reinforcement like that, then you can use AS required. Why you need to go to AS and provided? But even if you would like to use as AS provided, but with this shape, then you still don't need to use the real bars. But with this tick box, in fact, you are combining two things. And now if I will go to the standard output preview, I would like to show you the new thing, also something new. Where I put it here. The new thing is, let me take it here. This one. As you can see, we little bit added a new column. We have the basic one, 10 to 100. The user input became 12, 130. And then the designed reinforcement, there is nothing, because this one, it's already covering what is required. What will happen if the reinforcement is less than? Let me make, for instance, this reinforcement quite low. Let's see, say 6 millimeter and 6 millimeter. I hope it will be less than required. I will calculate again to show you what the scenario will be. So here I have 6. As you can see, SCIA recognized that the 6 is not enough. This is the 6, and then you need extra. The extra from where it will be calculated? It will be calculated from here, from the template. The extra will be calculated from here. What I'm going to do, I'm going to make it 0 to see the difference now. Now I should see insufficient in that case, because I fixed, and then as you can see, insufficient, because I fixed the amount and I switched off the additional reinforcement in order to be in the safe side. SCIA will tell you insufficient, and now if you will go to the output, you will see not okay somewhere if I'm in the right location. Okay, I am not. I need to be here in order to see not okay. Anyway, basically, this is the new improvement regarding the slab design or the wall design. There is also something I would like to mention quickly. This is already done. Now the question is, can I use those combination of real bars with the template reinforcement in the checks? Yes, you can use them. And what's new now, if I will go to the cracks, for instance, you will see you have what is it? Wait, let me check here. Yes, for the punching, for instance, provided and user. What's the meaning of that? In fact, it's a combination of the two. If you would like to use the only user, now if I will run the punching, then SCIA will rate only this reinforcement as a longitudinal bar inside the slab. But if you would like to combine both, which is the basic plus the additional one, then you need to use that. If you will deactivate this tick box, then it will be provided, and then those real bars will not taken into account. This should be the same scenario also for the cracks. For some reason, I don't see the tick box where I can activate the user reinforcement. It could be this is a bug. Yeah, normally it should be user plus. Also the same scenario for the CDD calculation, where I can use the both, the user and the real bars. For some reason I cannot see them, maybe because I am using old model, not made by the new one. This is also something I would like to mention to you. If you will open old model made in version 18 in this new version, keep in your mind that you will see those values as deactivated, like that, and this value as 0, in order to avoid any conflict. All old models will be use those settings, but with the new version, no, you need to activate them, and they are active by default. So the usage of those reinforcement in the checks, it's also possible. Next item, it's export of the reinforcement via ASF. If you are friend with Allplan, then probably you know this functionality where you can export the reinforcement from SCIA Engineer via a small file, we call it ASF, and then the draftsman or the designer or whatever you call him, the guy who's using Allplan, he can import the result from SCIA Engineer directly inside Allplan. I think this will also save a lot of time. Last thing I would like to mention, it's about the improvement that we did in 18.1 for the ribs. With the ribs now we have a new methodology. It was released in 18.1. If you will activate the rib action inside the menu, then SCIA in fact will split the 2D from the 1D for the calculation of the stiffness. The 1D could be calculated in two different ways based on the location of the neutral axis. So either it could be split to two small pieces, and then we will merge them and calculate the stiffness, and then the 2D will be also calculated. Or if you would like to deactivate, then the scenario, it will be quite simple for SCIA to calculate the stiffnesses before the calculation of the deflection. Next thing, good news for anyone in the Netherlands. Now we are supporting the new National Annex 2016. I think the main difference it was about the calculation of the cracks K3 and K4 factor. Now it has been updated, and what we have today is 2016. For our clients in Denmark, now they can design 1D member, 2D members unfortunately without punching, because somehow the punching according to the Denmark, it's a little bit different from the standard Eurocode. But they can design 1D and 2D, they can do checks, section checks, all that it's supported as well as long-term deflection. All that is supported for the Denmark. Small improvement also to the guys who are doing concrete design based on the SCIA code. We improve the CDD calculation in this version. Finally, what I would like to say before start reading your question, the new way to design the shear reinforcement, really I hope it will save a lot of time for you. Automatically calculated zone under your control, of course. And also we gave several options where you can make the final longitudinal reinforcement practical. Now with one click you can do the design for the entire building. You can call all the reinforcement in one click, and you can go to the checks, and based on the color you can understand where is the problem. Okay, exactly on time. It's 1 hour now. So please feel free now to type your question. You can type all the question that you would like me to answer. I will answer as I can today, but the rest it will be, of course, for later. So I will mute myself a little bit to read the question. Well, I have now three questions. The first one is about the anchorage. As I said, the anchorage, it's not calculated, but you can add them manually as a value. This value will not be controlled in SCIA Engineer. It's just from the visual point of view, we decided to add them. I'm working on it. I hope it will be fixed in the coming release, not maybe in the 19.1, but my plan is to do it in 20. Next question is about you have a continuous beam in this direction and then another continuous beam 90-degree perpendicular on it. What will be the scenario? If what I understand from your question correct, then in fact nothing will be happen, because it's difficult at this moment. It's difficult to see an engineer to connect this point of the intersection in that direction and then in the same time connected in other direction. So there is, in fact, there is a workaround where you can make a link between those two nodes manually. And in that case, you will get somehow the uniformity or the action of the continuous beam. Next question, can I export the result to IFC, Revit, etc.? Yes. Maybe I didn't show you that. Let me see. For instance, I have this one. What I'm going to do, file, export, IFC. I will give it any name, put it on the desktop. Save. Okay. So now all the reinforcement is exported. What I can do, I can go to this is my file. In fact, I have small application. It's called BIM Vision. It's just to show the content of any IFC file. As you can see here, transparency. As you can see, all the reinforcement has been exported via IFC file. It's not all a plan or Revit. It's a simple tool, but the idea is still the same. I saved them as IFC and I export them. Okay. And next question. Is it possible to define maximum length of the bar? No. Maximum length of the bar in reality it is 12 meter. My plan was to do it, but then due to the priority of other things, I skipped this one. So for that reason, if you have a very long beam, then you will see the bars. It's more than 12 meters, so you will not have it. And of course, if you don't have maximum length of the bar, you don't have what we call it overlaps between the bars. But this is in my list. I'm going to fix them. A nice question. The question is, SCIA calculate the required reinforcement based on the cracks width. I will mention it again. What we have today, it's for the ULS. All the calculation of the reinforcement for 1D and 2D member today in SCIA Engineer, it's for ULS, so there is no cracks in the background. For that reason, what you need to do after the calculation, you need to convert all the bars as I did, and then you will go to the stress limitation, cracks calculation, and then just need to hit OK. If the reinforcement is OK, that's it. If it is not OK, then you need to make some iteration by yourself by increasing the reinforcement. As you can see now, accidentally I have everything is OK, but it could be not OK. And in that case, you need to put, you need to come and play with the local bars, just because we don't have ULS SLS design in one click. Detailing drawings. Maybe I can tell you a secret, but please don't mention it to anyone. We are working on it. The plan is to fix all those things and not really make detailing drawings in SCIA Engineer. But my point is, I would like to save the time that you spent with your draftman. I'm sure after the design you will spend a lot of minutes or hours just to make the hand sketch. What I would like to do, I would like to convert those hand sketch to something printable in SCIA Engineer. And then you can give those sheets to the draftman to continue. Keep in your mind, we are special software in analysis and design. The drawings, quite difficult topics, because the drawings in France, it's completely different compared with Netherlands or compared with UK. So making just one final drawings, it's really nightmare for me. So what I'm going to do, I'm going to make hand sketch. And this is also something difficult, but I'm trying to collect as much as I can to make the hand sketch possible in SCIA Engineer. Next question. Is it better to design rib or section? Not clear. I don't understand. Anchorage length for the edge of the reinforcement. I think you're talking about hooks. Hooks not supported in this type of reinforcement. How about concrete cover for real mesh, where for me SCIA take the cover for calculation? Well, I think you are asking about 2D member, and then the cover, it's already defined. If you are defining the real mesh, then the cover, it's defined there, right? If you are doing automatic calculation, then the cover, it will be taken from the automatic calculation. I'm not fully sure if I understand the question. Is that also for ACI code? Unfortunately not. This is only for the Euro code. Another question about hooks. Punching for walls and corners. I hope soon you will get a good news about it. This is the maximum that I can tell you. Can you export the reinforcement to Revit? In this version 19, no, but we are working on it. The plan is to make it possible in patch 1. So version 19, patch 1. I don't think I will continue like that. It's already 10 minutes after 1. So really, I thank you all for this huge amount of participation. I'm quite surprised with this huge amount everywhere from the world. So I'm quite happy. We are doing all the best to make SCIA Engineer and specifically the concrete design really nice to use. Always, if you have any question, my email address is m.altai@scia.net. I'm the supervisor on the concrete design, so you can send me any feedback or any remarks that you have it, and together I think we can make something good. Okay, I'm going to stop the record and stop the webinar. After the webinar, you will get a link with the record. Thank you guys, and see you next time in next version. Have a good rest of the day. Bye bye.